How's it going?
Oh, right. Yeah, it's on the I have dual boot computer, and on the Linux side, it's audio. It's not so great. So I never know.
Yeah, it probably doesn't have good integrations with the audio drivers.
So there are like some packages that people install that help on that. Yeah.
Do you have a GPU locally on your machine?
Not anymore. Like I had it on my previous computer, but that was it was just bad combination. Really powerful GPU, thin laptop, and it was just you know, it was freezing.
I wonder if it would freeze and also be super hot at the same time. Because wouldn't it heat up in a laptop?
Yep. Yeah.
So what do you do? Do you need GPU on a regular basis, and what do you do?
Yeah. So now I use AWS. I would just pick like a instance with enough GPUs.
So you basically you directly use a VM.
Yeah.
So you start a VM with GPU, you SSH in, you run your code in there. Is that your main way of doing?
So I haven't been doing it that much, but for heavy training, yeah, that's what I do.
Have you had to scale beyond that, like using Kubernetes or something?
No. Just a second. I think basically with AWS you can actually just get like a bigger GPU. So that's it costs more, but not it's not. It's really easy to replace.
Yeah, and this is my bird Augie. So, right, and you've been. Is that when you did like stuff with BERT?
Yeah. So actually, I did a lot of training on my old laptop locally, but yeah, now it's a remote, and then some of it is you can do like a Jupyter. You can run Jupyter on remote server. That worked pretty well.
Yeah.
I have to. I'm spoiled by Jupyter, but so now I actually have to run real code. So it's more.
Yeah. Jupyter's great when you're experimenting. You're figuring stuff out. I'm totally spoiled by it. I force myself to use it so I don't go down the engineering path, right? Too soon. So I've been having this thing with I've been using Colab. Hey Suji, we're just talking about. I'm leading a discussion here on GPUs a little bit. Can you hear us okay? Okay.
I can hear you.
Yeah. Now I can hear you. So the reason I'm sort of asking about it, Yuri, is that I've started doing the simple transformers, so using Roberta, and starting small, got really good baseline on 10 topics, like over 90% precision and recall, right? But I have to go up to 5,000 topics now. But I've been getting roadblocks because Colab. I think maybe it's because I left Colab open, a GPU Colab open. Even though nothing was happening on it. And so they cut me off from GPU. Okay. So the next day I couldn't do anything with GPU. I'm like, this is time to figure out how to deal with this. And so I started trying out GCP AI platform notebooks. Have either of you guys know anything about that?
No.
Okay. If you guys want, I'll quickly show it to you.
Cool.
Just to get a rough idea. So they have an old one. They actually just came out with a new one called, it's the same thing. It's AI platform, but in parentheses, it says unified. Because, first of all, if you look at all the stuff they have, it's not unified. I know that. there's stuff all over the place with Google. I mean, and they're sort of trying to bring it together as a product. So so it's nice to see them doing that. But my point was to open it up and use a notebook and get GPUs. Of course, I got pretty far, but the problem was I needed to get more. This is my personal account, and I needed to get, what do they call it? I needed to request
additional resources.
Yeah, resources, because they don't just let you use things. Like if it's something new you haven't done before, they kind of ramp you up. So I actually had to send emails yesterday to get more GPUs. So I'm a little stuck at the moment, but I'll show you what I explored. Okay, it's kind of cool.
Yeah, I just saw in kind of discussions today on how it's more difficult now to get good GPUs on Google Colab.
Oh, yeah.
It's happening to everybody, not just you.
Yeah. Okay, that makes sense too. Okay, so this is it. So I'll show you something though here. So you see how it says AI Platform Unified? Right up top left, can you guys see that?
Yes.
Okay, so I'm not on satellite now. It shouldn't be as big a lag, but okay. So here, I'll just show you if you go into Google GCP. You guys are GCP guys. You guys are both Amazon, I think. But either way, you see how there's two of them under artificial intelligence?
Okay. Okay. Right.
Yeah. So
and not.
And the AI Platform Unified is the new one. Okay. I just happen to have it pinned up here. So let's go to that. And now I don't understand it that well. I'm just using the notebook part. And what you do is you spin up a server, a notebook server, and then you open up, a notebook and you start working with it. Now I'll do that real quick. So there's your notebooks. I don't have any servers now. I've shut them down. So let's create a new instance. I'm going to choose a Py. So these are different images basically, right? Pre-populated with different stuff. And the PyTorch 1.8, I'm going to use that one. Okay. And I'm going to do it without a GPU because you can then accelerate it afterwards when you're ready for the GPU.
Okay.
You can add it in. You have to restart it, but so then here's your configurations. And you can see it's a small machine. This is smaller than my local computer, right? 4 CPUs and 14 gigs. So I usually increase that, and you can do that with the advanced options. Let me just do that real quick. Just so I don't create a completely useless server here. I'll just go up one. So there we go, 8 CPU. And I'm going to create it. That'll take a couple minutes to create it. So while it's spinning it up, that's my notebook server. And while it's spinning it up, let's look on the left side here. And what they're trying to do, okay, is you have data sets, right? So that's the beginning of the pipeline, right? And then you have a labeling task. So maybe you need to interact with humans.
Mm-hmm.
Use the Google labeling services. You pay for it. I don't know how it works. And then there's training. I don't know how that works. Let's go to it at least. I haven't used this, but this is sort of their like no code democratizing machine learning for everybody tool, right? This is like their beginning of that. And so here's your training, and you could have a training pipeline and custom jobs, and you can do hyperparameter tuning. And then there's models. So I guess when your models are done, they get stored here. And then you have your endpoint. So of course, an endpoint is where you serve your model and you can query on your model. And then I guess batch prediction, I guess you run stuff on your model. So you can just see it's like all steps in the machine learning process. Very and nice, they're trying to turn it into a GUI. Now, if you go to something like some of these, what they're going to end up doing, let me take a look here, see what happens. Like for training, my guess is you're going to end up at Kubeflow in the back. But this is also a platform for AutoML for them. Like the way you usually most people are going to enter into this AI Platform Unified is through wanting to do AutoML. So you've got your AutoML option, right? I don't know what I guess Edge is IoT, and then you have your custom training, right? So I don't know, maybe I'll grow into using this in a way. It's good to know how to do that stuff, but right now I just want to use notebooks so I can have, I can have GPU. But what's really cool is, let's open a notebook. I'll just show what I was able to do, which you're not going to see it here, but I'll explain it. Is first thing I do is I had some issues, but see, that's Git, right? So Git's kind of built in. So you can clone your Git repository right into here. Sorry about that. Sammy, this is the little guy that screams all the time. He's a little Sam. He picks. He's always done it his whole life, poor guy. So he wears a cone a lot of the time. But so the point is, you can clone your Git into there, and you can manage your Git code. It has a Git plugin here, and so you can it's not showing it here, but you can update, you can clone, and you can update and manage your code, which is nice, right? Suji, we were talking about projects, and if you have a specific project, there's also a Git repo. You can just clone it in here and start working on your notebook and have GPU available. So that's my goal. And the one problem I had is it's like an older version of Jupyter Lab, and extensions, I couldn't freaking get the extension to it. That drives me crazy with Jupyter when there's extension problems. And in this case, I really heavily rely on table of contents on the left side. And so it's like annoying the heck out of me right now that I can't get the table of contents extension to work. So like everything with Google, it kind of, even though it's like a front end thing, you have to be a freaking engineer and you have to know the details, and it never just works the way it's supposed to. That's my experience with Google. I mean, it's great stuff, but it's a little annoying. And the other thing with DVC, I've had some issues with DVC, but I don't think it's the Google platform problem. I think it has to do with the fact that I loaded DVC, like I saved DVC, I saved data files via DVC into a remote Google Cloud Storage bucket. However, I did it from Windows.
Okay.
I think that screws up the paths.
Oh,
because then I'm on Linux, which
CRLF.
It really shows it, which I wish it would just know how to deal with that, but it doesn't. And it just shows sort of a systemic problem with how I do my work, which is it's in containers, but when I'm on the VM like this, you want to just, a lot of times you want to do machines. You're doing your stuff on your machines, like you Git cloning or DVC. I don't do that all within the container. I do it on the machine. And so probably I should be using Windows subsystem for Linux, right? So I can be doing everything from there, but I don't know. So anyway, I think that's all I have to show.
There might be also a configuration parameter in DVC where you can say that, prefer line feeds versus carriage return line feed or something. So that's something to look at. I don't know for sure, but maybe there is.
And then when I switch environments, well, see the DVC files themselves. Oh yeah, you mean, but then it wouldn't work on Windows. You know what I mean? I still have to kind of like switch it between.
Oh, I see. Okay, you have to smart change it, right? Okay.
Yeah, and the .dvc files, they have a path. That's where the problem is. I mean, there's not just a hash, there's also a path. And so those paths get set by whatever environment you're in, I think. It took me a while to figure out what was going on, but so I'm still trying to make this all work well, but yeah. Anyway.
You might find, I don't know how the pricing is, but Amazon had a similar thing with SageMaker, where they had, a notebook environment, but it was primarily meant for model deployment, right? So, using it for development was actually a pretty expensive operation, compared to having your own EC2 box and running Jupyter Notebook on it, and basically running the server there and working on your local machine, right? So, cost-wise, SageMaker wasn't a good deal if you were just going to use it for notebook-based development, right? So, I don't know about the pricing for Google. Azure has a similar notebooks environment. It's purely notebooks, and I think that makes a lot of sense for if you don't want to mess with your own Jupyter server. But yeah, so maybe Google picked up that model. So
the pricing is and this is similar for almost everything on GCP. It's just resource utilization.
Okay.
So you don't pay anything for the AI platform. It's just
I see. Okay.
they are dedicated servers,
Mhm.
right? I don't know if you can do preemptibles, which kind of sucks, but
Okay. So you don't pay a premium for running notebooks on the unified AI platform versus somewhere else. Okay. Okay. In that case.
Yeah, I think it would cost exactly the same on a VM.
Okay. All right.
You know,
In that
directly.
case, it totally makes sense. Yeah.
I mean, that's what they're doing now, right? Probably for the next 5 years. All this stuff gets worked out, and then I bet there'll be more to it. But
So price-wise, it's the same as GCP.
yeah, it's the same as using it's just GCP. It's just using the resources, whatever resources you use, which is more than just the VM. I mean, there's Google also charges for, sometimes there's certain networking things, whatever typical cloud costs are. They do not, for any product I've used so far, they don't layer on an application cost.
Okay.
So yeah. So in other words, I could be doing this on a VM, right? But I'm like, something like this could make it a lot easier.
Exactly. If you're going to use the other stuff, it's all nicely integrated.
Yeah, and that's the hope, and that's how you stay ahead of the curve, right? Because can you leverage AutoML somehow in the future? I'll try it out. I heard a podcast from a guy who works for Hugging Face now, and he's leading up the Auto NLP project at Hugging Face. They announced that a couple months ago, Auto NLP, and he was like, it's great because you just run the Auto NLP and it'll run on a ton of different models. And then what you could do is choose the one that's the best and has good hyperparameters. And it's a great baseline, right? I mean, it's more than a baseline, obviously, but it's like probably, at least for now, what that gets you is like, eliminates a lot of the experiments and questions, are you using the right model or not? It gives you a really good foundation to work from. So that wouldn't be a bad thing. I'm not going to do that now. I'm just trying to get multi-label classification working, but I was hoping with this, I could start using a platform that helps a little bit. So we're going to all need these kind of things to keep up. So it's a little early for a lot of them, right? Waste a lot of time on these things. So. All right, I think that's all I got. Anything else to say on that? Okay. I know, Yuri, you were looking at the NVIDIA conference stuff, right?
Yeah, I haven't listened to. I think I've listened to a couple. I haven't listened to anything since the last time we met. But there's actually a new conference going on right now. There's a graph conference going on.
Yeah.
But I haven't listened to anything there because just no time. Also, like I listened in the beginning, and it was like a business talk, so I decided, I don't want to.
This is the Graph AI one, right?
Let's see. I was trying to find it.
Anaconda also announced was that this Thursday maybe? They also have a graph, data science graph modeling discussion presentation. Anaconda, those guys do.
Yeah.
I'm on their list, and you get what their talks are going to be and so forth.
Oh, that was yesterday, right? I mean.
Oh, it could be. Yeah.
Yeah, it wasn't great. I attended that. It was mostly basic graphs, and they talk a little bit about network X, and they talk a little bit about bipartite graphs and how they can use it for recommendation systems. So it's not like very, very cutting edge or anything. It's fairly basic.
Yeah, I mean, the stuff that's really crazy interesting is an embedding space, right? A graph embedding space. I mean, wish I had time to play with that. So,
well, I mean, graph structure-based algorithms are also, interesting. But this was kind of the bottom of that, right? So graphs are nodes and edges. Everybody knows that, right? Betweenness centrality, used for finding out transportation bottlenecks. Again, kind of follows logically, right? Then what was the other one? The other one was
recommendations. Yeah.
No. Yeah. So there was this. He did three things, right? I can look it up. Hang on. I have these open even now. Okay. Graph analytics. Yeah. So transportation network bottlenecks. That's what he used. Betweenness centrality, and he also mentioned max flow algorithm variance, which he didn't explain anymore. I mean, but that was kind of the his thing on that. Oh, the bipartite graphs and recommendations. So that's a fairly old idea. And then he did community detection, which was kind of nice because he took a bipartite graph, converted it back to a monopartite one. And, so if you think of, say, you got users and you got products, right? And, so this is like a bipartite graph because you have two classes of things and you're linking them together, right? And then you want to see, find me similar users based on product usages, right? So you basically eliminate the edge. So any edge that, or any node that points to one node here, and a pair of nodes that points to a single node, you basically connect up directly and you eliminate that one, right? So that's how you convert a bipartite to a monopartite. And then he uses Louvain community detection to find similar users. So that was cool, I thought. I mean, again, not a new idea, but I hadn't seen that done before. So in that sense. So he did three little use cases, which were quite nice.
Oh, that's interesting. Yeah, I like that, how you can reduce the graph in that way. That's cool.
Right. Yeah.
Yuri, did you find what you saw?
Yes, I sent the link to the conference. It's sponsored by Tiger Graph.
Mm-hmm.
And I guess you can register and watch it later.
Okay, Yuri, you got anything else of interest, Yuri, going on?
By the way, since we were talking about graph embeddings, I think a couple of weeks ago, and I think Sujit, you recommended like two ways of doing graph embeddings with NLP, and I forgot what they are. Like, I haven't been able to work on that part of project.
So the very basic one is deep walk, right? Essentially, deep walk. So okay, let me write it down
deep
here.
Walk.
Yeah.
Okay.
You're just
okay. Yeah, I think I remember. I started looking at it. It's basically kind of random walking and adding.
Exactly.
Okay.
Right. So
are you
I'm sorry.
I'm sorry. Is the idea basically you're turning pieces of a graph into a sequence?
Yes.
Okay.
Random walks in a graph into like sequences of nodes.
Little chunks. Yeah, like sentences. Everything's
exactly.
a sequence.
And then you do what to back on them. That's all it is.
Yeah.
Well, that's what deep walk is. Node to vec has some additional things where you can go forward, but with some limited probability you can go back. More page ranky, right? So it adds some additional constraints on your work, and so they claim they get a better better results in terms of finding node similarity, and experimental results also bear it out. So that's always there. The other one that I was looking at was Spectre. I haven't figured out exactly what they do, how they generate it, but it's a combination of the content and the graph, right? So in that respect, so it's not only just the reachability from one node to another, right, which determines the embedding. It's also the content of the node itself, right, which or on the path, right. So so that's called Spectre. That's from AI, OpenAI. And, so that's another thing I want to figure out. I think they have already published how it works, but I don't know how it works. I just know that it exists. And
so let's say you've done it and you have any of these methods, you end up with an embedding space at the end, right? And then what do you do?
So these basically, you have an embedding space, and then for each node you can calculate the vector, right? The position in that embedding space. And so that's like a 512 or a 768 vector, which you can then use for vector
everything. Yeah, for everything, right? You can use it for everything. What's interesting about it to me is if you have a real graph that has real interesting data and you do this, maybe you have to do it in a limited way, right? Only certain entity types or certain node types, right? Because you get all, I don't know how, I think it would be weird to do like a really rich graph in this way where you have like 50 different types of values and, stuff like types. But either way, I would assume you would then use some sort of vector stuff, and then you could key back in to your graph and extract more info from the graph. That seems intuitively very interesting.
That's what Neo4j. So pre-embedding. Neo4j has another one which is like really, really lightweight and fast, which I don't remember, but they offer it as part of their standard graph package, right? An embedding. So they have three. I think they have Node2Vec, they have DeepWalk, and they have one other. I think fast embedding or some. It's called something fast something or other. But even before that, the standard way of doing graph-based classification was to find graph features, right? So you take a node and you say, okay, how many edges does it have, right? Or what kind of thing is it, or what are the distribution of its neighbors, so things like that, and you use them as features for those nodes, and that's a feature vector which you attach to your node, and then you do classification on them.
Okay. Yeah. So this, I found Spectre from OpenAI. Was that the one?
Yes. Yes.
Not OpenAI. Sorry, Alan.
Yeah, it's probably Alan. I'm making okay. I'm mixing them up. Sorry.
I mix them up also all the time because like they're West Coast.
Right. Yeah.
I think they're both in. I don't know if both of them are in Seattle or OpenAI is in San Francisco.
Alan AI is Paul Allen. That's the Microsoft guy. Yeah. And OpenAI, I'm not sure where they are. They are the GPT guys, right? Yeah. Okay.
Yeah.
So I don't understand the feature base. So doesn't that have to be turned into vectors, or is it a different type of problem? Okay.
Yes. Well, you can think of it as if you think of tabular data structures, right?
That's what I was thinking of. Yeah.
And you basically create additional features out of whatever you have, right?
Right.
Similarly, here the nodes are think of them as rows, right? And you compute additional features based on the structure, right? So is it part of a triangle? That's another one, right? So typically, if you have three nodes connected together in a triangle, that's a very, very strong bond. And that actually signifies much bigger. So again, it's like a heuristic, right? So triangles are special. So
you have these features, which are like a structured data set. And then do you do create an embedding space from that, or you just say you use different algorithms to do class? Typically,
you could do either one, but typically you use a typical classification algorithm that takes categorical features or something, right? So, but that's a feature vector, right? So,
Right. Okay, now I understand it. So, do you have in mind when these sorts of, particularly the graph embedding stuff would be? I mean, look, if I have a graph, right, I might as well just try it.
Right.
But what if I don't? I mean, or when would this be like the core move I should make?
Well, when
What are some of those examples?
so
Yeah.
one way is I've used graphs in text, because even though it's not structured as a graph, you can create. Sorry, yeah, go ahead. Yeah.
Just straightening my bird out. That's all.
So,
Keep them from destroying things.
Okay. So so one, I try to do commonalities, like if terms co-occur in a certain paragraph or something. So you could kind of manufacture these relationships and then use graphs on it. So almost all the times I've used graphs in NLP, I've used some kind of structure that is implicit in the text. Trying to basically.
Well, I mean, you're in the science literature, so that's what references are. So that's the fundamental graph in your world, and you're sort of
that is
using
already
that.
Existing, right?
Yeah, but you're sort of leveraging that idea, right? Because it's like points in a text that relate the two texts together. Right. So you're taking an entity probably, or maybe a triple or a fact, and you're saying that same fact is in all these papers or whatever.
Exactly, right.
But what does that buy you? Why would you do that?
It buys you, so typically if you have these edges, they give you longer distance relationships, right? And which are not readily apparent, if you look at them just on their content alone.
Right. Longer distance relationships. That makes a lot of sense. Right. That's interesting. Yeah. I get it. That's a good context. That's an interesting. That's a good use case. Yeah. Very good. For in the NLP world in particular. All right. I guess we were kind of still. Yuri was still driving the direction here. So Yuri, did you have anything else you saw or heard about or want to talk about or share?
Nothing. I actually have a question. I guess more for Sujit, but for you also. So so some time ago you were showing the vector search with Vespa.
Mm-hmm.
So and then you said that basically Solar also has vector search now, right?
Solar will have its patch in Lucene, so once it gets imported. But Elasticsearch has a plugin which allows vector search.
Okay.
There are issues with that plugin because here compared to between the two, Vespa seems to be superior because Elasticsearch's plugin does vector search per tree, per segment in there, and then they aggregate the results across segments. So what happens is that since segments are created dynamically, over time there might be drift in the results, right? So your vector search results might be slightly different over time for the same query, right?
By segment you mean the different sets of data, the way it separates it out.
Right.
Like
in multiple
shards.
files internally.
Yeah.
And it does that dynamically, even when there is no data coming in based on traffic patterns. Right. So
yeah. Well, Vespa's the native solution.
Right.
Built from the bottom up, ground up for that.
Yeah, exactly. Yeah.
Okay. So I wanted to kind of, I think wanted to repeat close to what you were doing. I have terms and I have embeddings for them.
Mm-hmm.
So basically, I want to find them in the text, right? Will Vespa do it for me, basically, or do I need to do some pre-processing, right? So my main question is, my terms are multi-word terms.
Okay.
So I use sentence embedding for their and it's not single word embeddings. But will Vespa be able to use it right away? Do I need to?
So you would need to store the sentences or the embeddings for the sentence as vectors in Vespa, and then on the query side you would probably want to typically, since you want to find the sense of the phrase in the sentence, you might want to do something like I did, where I ask for a sentence and the phrase in it, and try to disambiguate, look for the closest match there. So so what I did was I used BERT, and then I would take the sentence embedding, like the mean of that, the
Mhm.
and then I would calculate just the the tokens that represents my phrase, right? And I get that and use that piece to actually query. So
you create phrase yourself. So you base a segment and say phrase goes from here to here, and then you look for the match.
yes.
So you have to scan your whole paragraph in a sense.
No. So the actual search that I did was I basically took the query vector that I got, right? So let's say John has cancer because he smokes, right? So okay, that is my sentence. I want to find John has lung cancer because he smokes. So multi-word, lung cancer, right? So I want to find instances of lung cancer in my data. So on my database side, or on my the index side, I have stored all my sentences as vectors, right? Using BERT and doing a mean of all the vectors, like 768 sized vectors, right? One per sentence. And then on the query side, I get my sentence and I get my lung cancer. I send my sentence to BERT, and then I calculate, how many tokens, or what is the token offset of lung cancer in that, right? And cut out that piece of the results that I get, right, out of that. So John has lung cancer because he smokes, right? So, and period. So eight words, right? So assuming tokenization is on space, so this will give me a 8 by 768 matrix, right, from BERT. So I would say that, okay, John has lung cancer. So 3 and 4 is what I want. So I would pick up those two rows from my matrix, mean pool them, and use that as my query vector. So it's a vector search. I'm not actually scanning anything, right? So, and it is not, you might not get exact matches. That's the other thing, right? Because this is a fuzzy kind of thing, right? So
how did you decide to, I'm assuming this is done automatically. So how did you decide to join 3 and 4 and do the mean of them?
So I basically, I tokenize the thing with the BERT tokenizer.
Yeah.
And then I find, look at my tokens, and then I, basically find the tokens that correspond to lung cancer. So because it does BPE, with that byte pair, not byte pair, it's called that special tokenization with the words like pound something, right?
Subwords.
Subwords, yes,
whatever.
yes. Yeah. So it might say lung and then can and pound ER. So it might be actually 3 tokens, right? Because CA and C might be too common, and or ER might be too common, so they split it up. So I would take all 3 of those because they correspond to my 2 words that I care about, and take the vectors and mean pool them, basically average them up.
Yeah, so that's what you get, that's what you're looking for,
yes.
Right? Because you want to look for lung cancer. So but how do you know, like, in this sentence, how do you find it in the sentence? You get score for every piece of it. So John, so your input, I guess you call it a query, right? John has a lung cancer because.
Yes. So my use case was a little different. So let me. So my use case was finding, what is the concept for lung cancer, right? So that is my use case. And so my inputs that I want, I ask for, is a sentence to put that phrase in, and the phrase for which you want the concept, right? And on my index side, I actually put in all the UMLS synonyms, right? So it matches all, and the vectors for the synonyms of all of UMLS, right? So it matches the vectors, and since the synonyms don't have context, they are not as good as lung cancer that John has while he smoked, right? So but so lung cancer by itself will be at one point on my space, in my embedding space. Smoking might be somewhere else, but my lung cancer that I got in would have some aspect of smoking and and lung cancer, right? So it will maybe be somewhere close to lung cancer, but also close to smoking, right? So the idea is that I will get a ranked list of by distance of my embedding versus the UMLS embeddings. So that's
that use case is a controlled vocabulary query
matching, yes,
use case. So you have an ontology of defined terms, and you're sticking them all in Vespa, right? Just feeding them in. I don't know if you're feeding them. You're feeding in vectors for them. So somehow you got the vectors already. Right. Vespa's not doing the vectorizing, and you're just feeding those vectors in.
Yeah, the vectors I got by passing through BERT without.
Okay. So outside of this, you prepared the data.
Right.
Right. Then you shove the data, which is just controlled vocabulary vectors for each word. And then you prepare your query the same way, right? That you prepared your controlled, and the query is not a sentence. At this point, it's just lung cancer. And you're trying to get back the similar and related and synonyms of concepts. So this is all controlled vocabulary concepts, which has nothing to do with sentences at this point.
But the sentence comes in handy here because, my primary use case was entity resolution, so ambiguous entities. So the sentence gives it the context.
Right. No, I understand. So when does sentence come in though? Because what you just described to me was Vespa search on controlled vocabulary, right? Where you're just trying to find other closely related controlled vocabulary, but there's no sentences in that yet.
There is no sentences, but my query is, if I just gave in the query, it would just be string matching, right? Because there is no nuance in here, right? Lung cancer is lung cancer is lung cancer, and it matches, one. But when I refer to lung cancer in the sense of smoking versus if I refer to lung cancer in the sense of small cell lung cancer, right? They're still lung cancer, but they're still nuanced by these additional stuff.
I understand. I completely understand. What I'm trying to connect to is, so once you have that rank list for lung cancer of other controlled vocabulary, probable controlled vocabulary terms, and you have them, then how does that relate to the next? What's the next step? Because you were talking about sentences before, and the full sentence had so many, but there wasn't. That was talking about what you were talking about. I get it, was preparing the thing. So you could actually have two different representations for the same phrase. Is that true?
It could be, yes. Based on the context, yes.
Yeah. So have you seen that? I mean, that's a huge thing, right? To be able to have, especially when there's single words. But anyway,
not single words, but phrases could be, or single words are actually more likely to be misplaced in context. The larger it becomes, the more,
Hey, sometimes single words are very important. So excluding single words that are already in phrases and doing this, and then, but anyway, Yuri, I think I've sidetracked your question, your use case. Did you get a conception of how to take next steps with Vespa?
Maybe I need to read the documentation. I think my problem is much simpler. I just want to essentially, like, I can think of this as like entity recognition in text, but I have my own entities.
Do you need to have exact match, or do you need?
No, that's why I want to. But that's why I want to use vector search, because I don't want exact match. Because otherwise, I could just do
Aho-Korasic kind of thing, right? So
because string matching lemmatization or something like that.
Okay.
Well, let me ask you something then. Are these entities you're talking about literally proper name things in the world, or are they concepts like topics?
No, they're like, agricultural things.
Yeah. So they're not like products though, or names or whatever. So cotton. I understand your use case. You said this a lot. Like commodities can have different, like a crop can have many different names for the same type of crop or a product or like, I get it. That makes sense. Because if they were very, very concrete, it's different doing this kind of fuzzy stuff. So, okay.
Can you well, you don't have synonyms for them, do you?
We do for like a lot of them. Like most famous is corn is maize. Like so half of the world says maize, half of the world says corn.
One of the things that a colleague of mine did, he basically ran using exact matching. He basically converted his data corpus into a bag of these entities, right? So wherever he found an entity, he replaced it with a number, right, pointing to that entity, or some kind of token which was, which would be thought of as a word. And then he did word to vec on it, right? And that gave him a space which allowed him to, take a new piece of text and encode it in the same way and find things that are close to it, right? So that's something that maybe you can look at.
But how does it include synonyms?
So we used an ontology where you have, lung cancer and carcinoma of the lung and so forth, all are synonyms.
Mm-hmm.
So, and they have like, maybe it's called C1234, right? Some intent by number. So when there is a text which says, lung cancer is caused by smoking, so it's a C1234 is caused by C5656, right? And that becomes like a huge piece of text. But with all the matches to the synonyms replaced by these numbers, right? And then he does a word to vec on these, and now each of these numbers become, because of their proximity to other numbers, right? They kind of have this, create this embedding space, right?
So look, if you didn't have synonyms, right, Yuri, you couldn't create a good embedding space, right? With some synonyms, you can create a good embedding space. This is what I'm postulating, why you need synonyms, because without synonyms, you're just not going to have as rich an embedding space. But if you have synonyms, you could still be missing half of the ways they're referred to, right? But because you have that net of synonyms, this word to vec will now is a good space to return similar terms that you don't already have as synonyms.
It's more like usage, right? So the known synonyms would be connected to each other via some, intermediate words, right? But even the unknown ones would be linked to those, or one end of those by some kind of those words, right?
Right, but if you don't have synonyms, your data is too thin.
Right, yeah.
To get a good word to vec. So, but we're
so in a sense, he would be taking a sentence and basically like replacing all the synonyms with one word or with one token.
That's what we were doing, yes.
I actually, and that's very much what I did with my synthetic tokens, right? I took, I do underscore. What I did is I took a document and then I took it's classified to this topic and to this product, right?
Mm-hmm.
And I took that topic ID and I did like a topic, you could do an underscore or whatever, but I did, I put the topic ID. Actually, I used the document itself as one of the pieces of the sequence. That was a document ID. I actually put the document ID with the full title, right? That was one token, right? So this is synthetic tokens, right?
Yeah.
And then, but you're turning a sentence. So then you have your topic, central tax /123, and I actually put, underscore topic, or I did it the other way around, topic. So you can immediately see this is a document underscore, this is a topic underscore. So when you get your result, and then a product underscore, and then also keywords that I extracted from the title. And then when I queried word to vec, I can immediately see, I got these 10 documents. Like you could put in this keyword or this topic, and you get these 10 documents. I get these 5 topics, these 5 products. It's the same thing pretty much. You're just using an ID for a token, but word to vec doesn't care. It's just that they're next to each other, right, or in the same sequence that matters.
Pretty much, yeah.
Cool. Thank you.
Sure. Right.
So is your goal with that, Yuri, mainly to build up your your vocabulary, so you get better recall when you're trying to say this data is for corn, you know?
Yeah, so we so the bigger goal, so we are building like our own like embeddings, because we have so so we kind of build it based on our ontology, so we can use train it on our data. You can maybe use graph embedding to like kind of make it more like basically adjusted to what concepts that are in our graph. And we also at the same time we're trying to improve search. So the idea was, well, since we're already doing our own embeddings, let's try to maybe use our own embeddings in search and see.
Yeah, right. You could probably plug those right into Vespa. You could plug it right into Vespa.
And that should work. And the search is actually for like recommendation for the user to what they should look at. So in theory, like our own meaning should work better than
right. So if you have your embedding weights and your vocabulary, right, that would be ideal input for Vespa, right? Because each of those vocabulary items would correspond to the row of your embedding, the weights.
Yeah.
And you could shove that into Vespa and then use your same embedding to calculate your query terms, vector, and try to do a similarity of that.
Yuri, what I'm a little confused about is the search for. What are the things that you're searching for? Are they documents?
So both document. So I'm thinking of documents because like that's one of the right tasks. We want to maybe like look at the text that we wrote or somebody else wrote and illustrate it with our own terms. Basically, give links to, corn, production of corn in this region. So we want to we can quickly illustrate this in text with links to the data we have.
So you're saying they'd search in Vespa?
No, this is not a search. This is sort of like search on the text.
It's browse and discovery, right?
Yeah, and then the pure search, like somebody says, basically writes a sentence like a free search. Give me, information you have on corn production in the state. So right now we have search that sort of starts bringing up like the right terms, but it's a pure, it's not modified with our own data. So it's not modified with the knowledge we have.
So there's different ways. So when you're searching, you'd be searching for documents in that case, right? Or for data or whatever.
No, we're searching for data. So we have database of data. We want it to be discoverable. So So we're adding new search already, but right now it's just I think it just goes by matching. So I want to see if like vector search will give us a better kind of richer suggestions.
So you could use it to augment the query and query processing, or you could use it, like Vespa's meant to be used right directly as using the vectors, right?
Yeah. Thanks.
All right, Suji, you got anything?
Nah, that's pretty much it. I was looking at how to put in, displacey stuff on Streamlit. So that's something I'll be trying out. So basically, I discovered that the dependency parsers created by Spacey's small English model really suck. The ones by the medium English model are better. And I want to now try the ones with SciSpacey, the biological model, because the end goal is to use it on biological sentences. So
are you using 3.0? Are you using Spacey 3.0?
Yeah, it's Spacey 3.0 throughout. but spacey small is what I used on our Databricks cluster to generate this whole bunch of like, I think some 174 million tokens or whatever. So it's, but I was doing the documentation for that. This is not for me; it's for somebody else to use. So I was doing the documentation for that, and I was using an example, and I discovered that the example that I had seen on my local box, which had a medium English model, right? I liked that, the forestry that came out, and suddenly the data did not agree with my forestry, right? So I couldn't, it took me a while to figure out why. I was suspecting my code. So I went back in my code, and my code was, for some, unnaturally for me, though it worked, right? It worked the way it should. But then I started looking at the spacey version. I thought maybe the Databricks one had an old version, and I have 3. I knew I had 3. And then I noticed that, the language model, right? And so I went back in, I loaded the small language model, and I regenerated my display, the rendering, and it matched the data. So, yeah, I mean, I was happy because it enabled me to do my user docs and, get it out, right? But obviously, the actual, the parse trees that I generated were not going to be as useful to the end user, right? Because they sucked. Right?
So when you were comparing core NLP versus spacey, right? You were talking about that painstaking kind of comparison you did. That was with the small model?
No, that was the medium-sized model.
Okay.
Right, because and that's what I have on my local box, and I didn't even think about that at that point. I have the medium one because I want to use the vectors once in a while, right? And the one on Databricks has the default small model on our cluster. So, yeah.
So you kind of screwed yourself for a little while. So you figured that out. That's not unusual.
Yeah.
Okay. So basically your conclusion was that that the medium one, it was different and it was kind of bad in some ways, but in effect, it was just as good.
Yes.
In terms of your particular task, and it's a lot faster so that you could integrate it into processes more directly. And so that was on the medium.
That is in the medium.
So it'd be interesting to see with the large too. And you're doing with your Streamlit, you're going to show them the spacey dependency parsing graph. Yes. I mean, I've seen that. I've used that. It's very nice.
Yeah, but that's what your main.
Yeah. Okay. So how you'll sort of present your findings with this.
Right.
Okay.
Well, actually the objective is to let them drive the decision, right? So I basically show them the first few and say, okay, this is what I found. Now you take a look. Here is a bunch of switchable models that you can use, right? And tell me, I mean, which one you prefer, right? And I'll just deliver it for you.
So are they gonna be able to use Streamlit to plug in a sentence and get it this core NLP way versus spacey way? Exactly. So you're synthesizing what you did.
Right. Exactly.
Yeah. Right. Yeah. Okay. So well, that's nice.
What do you need? So actually, I was looking at Displacey this morning, but your displays are purely Streamlit, right? That's what you were showing us maybe like about a month ago or so.
Yes.
Okay. I was actually thinking, so because you mentioned that was you can bring different embeddings and different into Displacey. I started looking at Displacey and trying to see if I can use that as my display.
Not embeddings. I can bring in different language models that.
Language models. Okay.
Yeah. So Displacey can do two things well. One is rendering the trees, and the other one is rendering entities, right? With
like a highlighting.
Exactly. Yeah. So that's what I'm not going to use it for the entity piece. I'm going to use it for the the parse trees.
And that's the main reason for that whole parse tree thing is so you could write grammar.
Yes. Yeah.
Rules.
But then why do you need Displacey and Streamlit?
So that
it's Displacey.
Yeah. Well, I mean, I could hand the person who is doing the bio stuff, right? The actual work, she is a data scientist. I mean, I could actually hand her over just a Jupyter notebook and let her do it on her own. But it's like the coolness factor, I guess.
Oh, okay. Yeah, we started using somebody in our company started using Streamlit to basically show internal data. So hopefully it will catch up.
Yeah, it is a cool thing. Darren, I have to thank for that, for showing us.
And I found out about it in at that conference where we met over a year ago in LA. That's what drove me to it. So, yeah, it's a classic, awesome tool if you have a proof of concept you want to throw across to the business people, particularly, right? And then you can work your way back technically, into more technical people. Still quite useful. So, yeah, it's wonderful. It's what's funny about it? It's actually a no-code. It's really a no-code app.
Pretty much,
right? Yeah. Which is kind of stupid to say because you're doing it in Python. But from a Python programmer point of view, fucking right, I don't have to do Node.js. I don't have to do any of that front end crap, which I don't have anything to do with because who's got time for that and data and machine learning. So it's really, from our point of view, it's a no code miracle, a low code, no code miracle. Yeah. I don't know, you guys. This is a little bit of a funny question, but I'm having real difficulties with handing off. Like, in the past, the work I've done was a project. I owned it. I wrote it. It integrated. This is the taxonomy stuff. Okay, I wrote a large app that runs in the background. It's pretty complicated, but and it's it's a repository, repo, and all that. And I've handed it off over. It took me 5 years, but finally, it's now owned and managed by IT or by our developers. But now I have these smaller things I need to hand off, and our company's not used to someone from the outside of the development team because I'm like embedded in a product innovation team, small team, just me and my boss. Now there's 2 people other, but I'm the only coder in that team and the only coder at the whole company that doesn't live within development. And so I do these proof of concepts. They can be small things or big things, and they get implemented. But they implement it wrong. No matter how much I spoon feed it. I mean, this is new. We're at the beginning of this. I got to train them. But, literally implement it wrong. It goes into production. They don't have me QC. I've got to get them to start integrating me into that whole process. And then we find out something's wrong. I'm like, who the fuck did that? You know what I mean? And the problem with this is that everything depends on everything, right? So the scraper, right? So I'm doing a automatic classification. No, we haven't implemented that part of it. But we're also doing page deduplication. Remember, we talked about that. So the scraping has to be working. Right. That's the code I created. How was that implemented? Is it working? If the scraping's not working right, everything else is in question, right? And then once you have the scraping, is the logic that decides 2 things are the same page working right? Well, if it's not, then you're already screwed. So now you're double screwed. And then I'm overstating it a little bit, but then you're doing your automatic classification, and did it not scrape right and all that. So, you know what I mean? So it's like all these things. When I do this work in a proof of concept, I spend a lot of time being very careful about the data and each step, because you're building on each one. And if you're not confident about each level of this work, where you get to building the model and the classification, all that, then you can't figure out what's going on. You know what I mean? There's just way too much complexity in this machine learning stuff to have any doubt about any of those layers where you're building up to using the model. So anyway, how do you deal with that? I mean, obviously I need to be, for some things that are more complex, I need to be part of the development team for the first year while we're iterating. You know what I mean? Like, this is innovation, right? So when it gets into their world, it's going to have to change very quickly for a little while because we're throwing it in there quickly. I don't know. Maybe it's different than your guys' sort of situation, but
my latest thing is testing or unit testing kind of deals. So try to, so in your case, perhaps, you could figure out some kind of unit test that prove that the scraper has done its job, right?
So you're going to automate me into a unit test.
Yes. So that is the latest one that I try out nowadays. Before this, I actually spent a year and a half in a development team. First doing some innovation, then doing busy work, so which didn't end very well, but well, I mean, that's a different issue. And before that, I actually, the first iteration, I basically handed off. I created the entire, the machine learning model and the pipeline to serve it. And that was what I delivered to engineering. And then
how did you deliver that, as a notebook or as a Docker container? Or?
No, as an application.
And
as a Flask application, which contained my machine learning model.
Yeah, that's funny.
Yeah. So all they had to do was hit it with a request, and it would spit out JSON back to them. Right?
Unbelievable. This is so funny. I mean, that's exactly. I'm sick of this shit. This thing's really complex. You guys are. I don't say this, but you guys are screwing up the simple stuff. So I made a Flask application, which right? And then I did it with Unicorn. Right. And then I did multi-processing pool stuff, and I just spoon-fed this whole thing. And now I don't trust them. So when you iterate, you have to redeploy it. Did you have to do that?
That was the problem. So when I did that the first time, I discovered that they didn't care about the machine. So it was like a complete black box to them. They didn't even want to see inside it, right? So when it came time for, they gave me new data, and I created, they got more data. So, they gave me more data. I retrained the model. It became better than previously, according to my tests. And so I said, okay, now it's time for redeployment. So I asked these guys, can you just hand off, can I just send you the model? And you guys just do it, right? And they didn't know how to, right? So that's when we actually got together, and I said, okay, I'm going to show you this time, and I'm going to write up instructions on how to do it, and you guys start picking it up at this point, right? So that's what I did. I wrote up instructions, and so the next time they came around, it was around 3 months later. I worked with them at that point. I did not do any work. They did the work, but I basically walked them through, do this. And from then on, they haven't asked me anymore. So there was another one where they actually took my model. So this was like one use case, right? There was another use case where I built a model using Caffe, right? So this is like before, and the model worked quite well. And then I handed it over to the guys out there, and they basically took the model, rebuilt it in Keras, deployed it, added a few classes to it, and they were totally on the other end of the spectrum, right? They took the model, they improved it,
right?
And I had to do nothing there. I mean, at some point,
I mean that's the best, because what you spend a lot of time doing now is like this. Is actually kind of like consulting, and you're like, oh, I've tried out this new embedding, this, that, and that, and then you go to somebody who would be interested in that, and you show it to them, and then they, it seems to me like you've been doing some of that. Right. So it's really more of an intellectual handoff when you have somebody like that, when you're in that situation, even though you handed off technology. Right. That doesn't count, dude. That's just an awesome situation.
Yeah, well, that was
it does count, right? But I mean, but that's not like handing it off to a development team. Oh my God. So what was wrong with the embedded situation?
The embedded situation, it turned out that they had quotas to fill. I mean, because I became embedded with the team, suddenly my time was kind of they had to account for every minute of my time. And so
you became a resource
to fill in my time. Which,
yeah, that's not your role. So there's a total cultural difference there. When you're on a product team, you are a scarce resource to be managed.
Right, exactly.
I mean, it's not fun necessarily. Not for guys like us who don't like doing the boring stuff, right?
Right. Yeah.
Except for when it serves our immediate purposes. So, yeah. Wow, that's like almost exactly all the paths that I've sort of inadvertently done. And right now, I'm hoping, I mean, after this meeting, I'll have a call too to find out, but that they'll just take my Flask inside Docker container with its own independent Git repo, hook, line, and sinker. Because if they take that, because the problem is I need to be, it's just Word to Vec thing, right? For automatic classification. I need to be able to replace it wholesale. Same contract,
right.
JSON. And also I need to be able to iterate. So a lot of these things, you throw them over the fence, you get them in there, and then I need to keep working on the code for the next 6 months, fixing it, changing it, updating it, and so anyway. So I get it. That's good though. If I'm embedded in the team, I'm not a resource, motherfucker. I'm not a resource.
I think that has to be made clear. I'm going into another one soon, and it's with the same. The director was actually quite unhappy with me for not telling him earlier that I didn't like what I saw, and he agreed with me that I shouldn't have been handled that way. But he said, "Why didn't you tell me?" So this time I will. No. I mean, if I see it. So
yeah, now you know the situation. So, what is that project? Why is that project one where you need to be joining the team?
This is a new. What's that called? It's a point of care clinical search. So the idea is that so the clinical search that we have right now is kind of encyclopedic. So it's for people who are looking for content, right? So if you are a doctor and you are looking for something that you have forgotten that you learned in medical school, right? Or a medical student trying to learn things. So more of encyclopedic, knowledge kind of thing, right?
Right.
We are trying to expand to point of care, right, on the bedside. So let's say the doctor has forgotten something and the nurse has forgotten something. And usually those queries are going to be much more detailed because, they are to deal with, they are to basically take action for a particular patient, right? Who has symptoms, who is, so you'll have much more data in the query. And conversely, you cannot get away with giving high-level fluff answers, right? So the answers will also have to be very contextual and so on, right? So that's the project.
So, but what I'm trying to understand is the nature of it that makes you embedded, and then also as being embedded, are you writing code or are you talking about configuring the search and testing the search?
Oh, writing code.
And so why in particular for this project is it important for you to be embedded?
It's, I think, more of like, it works for both sides this way. I bring in certain skills, they bring in their, their data, the large data skills. And, that's basically why.
Well, I mean, I think I kind of get it in the sense that the reason it came about was not because you asked for it, it's probably because you're the search guy.
I am question answering and search, right? So two things here.
Yeah, and you're known,
right?
Of course, even within the devs and all those guys, because you've been in there before as well.
Exactly. Right.
And so they're thinking, we've got this new search project. We want Suji to be part of it.
Right. Well, obviously. This search project has been going on for a while and hasn't been very successful because wherever we go, we kind of end up with an upper bound that we cannot cross, right? So yeah.
So they're bringing in the big guns.
Yeah, kind of. So, yeah.
Just giving you shit. So in terms of code, are you going to be working with Vespa?
I might. Yeah.
Okay, so part of it is an intellectual brain architecture, solve problem thing.
Yeah.
And then in implementing it, you'll probably be dealing with embeddings and all the stuff you've been talking about.
Very likely.
Maybe, yeah.
Because this seems to be more like a question answering kind of setup, right? And I might also, I've been trying to float the FAQ idea where it's, a combination of manual curation and or computer-aided manual curation of answers and question matching, right? So if the query matches a question that I already know, then I will give you the answer, right? So, or otherwise I will try to look it up from the data set.
No, I get it. That's a good combination. And but also, this is very much like a squad kind of thing, because in a way, a doctor might want to see an answer embedded, right? within the text.
Yes.
So it could be a search and then.
Oh yeah, of course. I mean, that's what we learned in Lexis. So they have a product called Socrates, where lawyers basically type in these long queries, question-ish queries, and it matches a sentence in one of their, I think it's called head notes, they call it. It's like case abstracts, basically, right? So, but instead of returning just the sentence that matched, their strategy was to return the paragraph that contained the sentence, because people want context. Just the answer doesn't cut it, right? I mean, you ask a question, you want to know why the answer is what it is, right? So
and the authority of the answer,
exactly.
maybe if you're a physician or whatever.
Right, exactly.
So this will be basically QQP problem in NLP, right?
Yes,
Quite similar.
yes. Well, one aspect of it will be QQP, I think, because if I already have an answer to the question, I want to return it, right? So that is the QQP part. The other part is probably straight up QA, if we can swing it. I mean, we don't know if we can.
What's QQP stand for?
Question pair. Well, actually, question pairs. Right.
Yeah,
So QQP, I think, is Quora question pairs, right? Well, it's not Quora here. It's just QP.
Yeah, but that's a problem that we were solving in the Kaggle for a long time.
Yes.
And it's sort of similar to it's similar to matches that we were doing. So that's why I keep looking at similarity.
Everything's similar to similarity. You could probably turn everything into a similarity problem.
Yeah.
You even make you could even take similarity and turn it into exact match practically.
Yeah, good. Yeah.
So was Lexus part of Elsevier, or
they're a sister company?
Okay.
So we are a bunch of acquisitions, right? Even Elsevier has companies which are like totally their own little islands. So we grew by acquisitions. So
it's Reed Elsevier as the parent.
Exactly.
Right. I used to, Yuri, I worked for, Jesus, I don't know how many years anymore, more than 12 years for Reed Elsevier. I was on the business magazine side of it, right, which was very different. It was Connors that was bought in the U.S. Connors is an old magazine company. And I was part of a custom content management system acquisition in like 2000. They hired me in to do taxonomy stuff, but I worked for Reed Elsevier for a long time. It was fun because I got to travel a lot, because Elsevier is sort of the Dutch side of it, right? They had their headquarters there, more or less, and then Reed was sort of the UK, and then Connors or what we were the B2B stuff, and then we had the guys in Australia. Did you hear of them? The Hot Frog?
No, I haven't.
Yeah, so I got to go to Australia a couple times. It was a lot of fun back then. But, and then LexisNexis, visited them in Ohio. So that was fun. Yeah. Anyway. All right, guys, that was good. Very productive. Is there anything else anyone wants to bring up or mention for next call?
So with throwing code over the wall, I was going to suggest testing also, like basically deliver with tests where, and maybe like package it so you tell them, well, this is the answer you should be getting, right? So that puts a requirements on them. So if it's not satisfied, then they'll come to you and ask,
I think it's a really good idea. I think that maybe if I'm able to do, I don't necessarily need to be embedded, but if you're embedded once, like I don't know what our testing practices are, right? Do we even do unit testing? So I would want to do that testing probably. God, I don't want to learn unit testing. I mean, it's kind of fun.
Well,
this kind of testing is difficult because it's data. It's harder to test data.
Yes, of course.
Right. So how would you do that?
Typically, you would say, okay, you could, make it scrape a hypothetical site that you contain in your case of, in your scrapey example. So you could have an internal site that, never changes. You scrape it, you should get what results you get, right? So, that's something you could basically mandate. And this is my scraper, your scraper should do the same thing.
Yep. And Yuri, what were you thinking?
Oh, I was thinking even like maybe like, so I know there's like a steps in scraping, right? So maybe like save the first what you get and feed that into the rest of the system. So you don't do the scraping itself, but like the rest of processing.
Ah, okay, yeah.
So
Which is exactly.
Then you don't need the website. But it's cool. It's I think it's more interesting to have your own website because then it's sort of like the full system test.
Yeah, I mean, it's all kind of, you just can't cover it all because part of the problem with their crawling is that they're crawling in GCP and it's our walled off GCP. And so it may be a network issue, right? So to really test all this stuff, what a pain in the ass. To really test all this stuff, I have to get, here is 1,000 URLs. You should get, 99% of these should be returned with HTML, right? The first step is to get the HTML. Now they change over time. So I'd have to host the site. I mean, I can't host the site, right? Because the thing is all network and whether GCP is getting through, if they actually have network access. So, but you guys are getting me thinking this way. And I think under certain circumstances, some basic data unit testing will definitely be worthwhile. When I can't just be a fluid part of the Q, I'd rather just be a fluid part of the QC. If they're going to hone the code and rewrite it or put it in place, have them do it and then get it into a QA environment, and then have me look at the code and have me look at the results. Because I just can't predict it all. And I would say that probably doing unit tests and data type unit tests and being part of the QC process is probably what I really want. But I'm asking for too much probably.
Well, you could do pairs. I mean, you could, in your list of sites to be crawled, right? You could snapshot a site and then you could look at the output of that site from Scrapy, right? And then, you choose a random site that worked and you choose the output of that, and then you compare it programmatically, right? Using high level, heuristics, aggregates, or whatever.
Yep. Okay. Anything else, anyone? Or for next call or anything? All right. Well, thanks, guys. Talk to you all next week.
Thank you.
Cool.
All right. Have a good week.
All right. You too. Bye.